Every rock beneath your feet, every breath of air you take, every drop of water and every ocean on this planet has a story stretching back 4.5 billion years, and almost none of that story involved anything resembling the world you currently live in. Earth has been a molten ball of rock with no solid surface. It has been frozen, nearly pole to pole, more than once. It has hosted nothing but microscopic life for longer than complex life has existed at all, and it has been struck by catastrophes so severe they erased the overwhelming majority of everything alive at the time, more than once. This is the story of how a swirling cloud of dust around a newborn star became the only planet we know of capable of supporting you, told across 4 distinct acts, each one stranger and more transformative than the last. Act 1, The Violent Birth. Roughly 4.5 billion years ago, our solar system existed as a vast rotating disk of gas and dust surrounding a young, newly ignited sun. Gravity, acting on that disk over a span of tens of millions of years, pulled material together into increasingly large bodies, dust into pebbles, pebbles into boulders, boulders into planet-sized objects violently colliding and merging. Earth itself formed through this same chaotic process, accreting into a roughly planet-sized body within the solar system's first few tens of millions of years. But the planet that resulted bore almost no resemblance to anything we'd recognize today. There was no solid crust capable of staying solid for long, no liquid water, no breathable atmosphere, just a surface kept molten by relentless impacts. Intense radioactive decay and heat left over from the planet's own violent formation. The single most consequential event of this entire first act happened remarkably early, likely within the planet's first 100 million years. A Mars-sized body, which scientists call Theia, struck the young Earth in a glancing, catastrophic collision violent enough to partially melt both objects and fling an enormous amount of debris into orbit. That debris coalesced, relatively quickly by geological standards, into the Moon. This single impact did more than just give Earth a satellite to look at in the night sky. The Moon's gravitational pull stabilizes Earth's axial tilt, preventing the wild, chaotic wobbling that computer simulations suggest Earth might otherwise experience over long timescales. Wobbling that could produce climate swings severe enough to make the development of stable, complex ecosystems considerably more difficult. Without that one specific collision, early in Act 1 of this entire 4.5 billion year story, the rest of this narrative might never have had the stable stage it needed to play out at all. For the remainder of this first act, a geological period called the Hadean, named appropriately after the Greek underworld, Earth slowly cooled while continuing to absorb a barrage of impacts from leftover debris still circulating through the young solar system, an episode sometimes called the Late Heavy Bombardment. By around 4 billion years ago, conditions had stabilized enough for liquid water to exist on the surface, and somewhere in this same general window, in chemistry, we still do not fully understand. The first act of this story ends, and the second begins. Life appears. Act 2, The Long Silence. This act covers an almost unfathomably vast stretch of time, from roughly 3.5 billion years ago to around 540 million years ago, nearly 3 billion years in total, more than half of Earth's entire history condensed into a single chapter, and for good reason. For almost this entire span, life on Earth consisted exclusively of single-celled microorganisms. No animals, no plants, no fungi, nothing visible to the naked eye. Just an ever-evolving, ever-diversifying world of bacteria and, eventually, more complex single cells, quietly transforming the planet in ways that wouldn't become fully apparent until much later. The most important event of this entire silent middle act happened roughly 2.4 billion years ago, when certain microorganisms evolved the ability to split water molecules using sunlight, a process we now call photosynthesis, releasing oxygen as a waste product. Oxygen had been almost entirely absent from Earth's atmosphere up to this point, and it was actively toxic to much of the existing microbial life, adapted over countless generations to an oxygen-free world. As oxygen-producing microbes proliferated, atmospheric oxygen levels rose dramatically in an event geologists call the Great Oxidation Event, triggering what may have been Earth's first mass extinction, wiping out vast numbers of organisms unable to tolerate the new oxygen-rich environment their own relatives had inadvertently created. This same long act also contains one of Earth's strangest and most extreme climate chapters, a series of events called Snowball Earth, occurring at multiple points, most dramatically around 700 to 600 million years ago, during which geological evidence suggests glaciers extended across most, possibly nearly all, of the planet's surface, including regions near the equator that remain ice-free even during today's coldest periods. Earth, for extended stretches measured in millions of years, may have resembled an enormous frozen ball, with life surviving only in isolated pockets, possibly around volcanic vents or beneath thinning ice where sunlight could still penetrate. What ended these extreme glaciations appears to have been the planet's own volcanic activity, slowly building up greenhouse gases beneath the ice over millions of years until the resulting warming finally overwhelmed the runaway freezing, and the ice retreated, in some cases, dramatically and rapidly, once the tipping point was reached. Act 3. The explosion of complexity. Around 540 million years ago, after nearly 3 billion years of overwhelmingly microbial life, something extraordinary happens in a geological instant, the Cambrian explosion, within a window of perhaps 20 to 25 million years. Genuinely brief by the standards of the previous act, nearly every major animal body plan still in existence today appears in the fossil record for the first time. Eyes, shells, jointed limbs, segmented bodies, the basic architectural blueprints underlying nearly the entire animal kingdom all crystallize into existence within this remarkably narrow window, following nearly 3 billion years where nothing comparable had ever happened. From this point forward, life diversifies and colonizes new environments with startling speed relative to everything that came before. Plants and animals move onto land for the first time around 470 to 400 million years ago. Forests, the first ecosystems to meaningfully transform the planet's atmosphere and landscape on a continental scale, spread across the land by around 360 million years ago. Throughout this entire act, Earth's continents are also constantly rearranging themselves, drifting, colliding, and splitting apart in a process called plate tectonics, periodically assembling into a single enormous landmass before breaking apart again. Around 300 million years ago, nearly all of Earth's landmasses merged into a single supercontinent called Pangaea, reshaping global climate and ocean circulation patterns dramatically enough to influence the evolution of every land-dwelling organism alive at the time. Act 4. The Age of Upheaval. This final act of our story is defined by recurring catastrophe, punctuated recovery, and an accelerating pace of evolutionary change. Around 252 million years ago, Earth experiences the most severe mass extinction in its recorded history, the end Permian extinction, eliminating an estimated 90% of marine species, triggered by a sustained catastrophic episode of volcanic activity in what is now Siberia that pumped enough carbon dioxide and other gases into the atmosphere to trigger runaway warming, ocean acidification, and widespread oxygen depletion across the world's oceans. Life recovers, as it consistently does throughout this entire story, and dinosaurs eventually rise to dominate ecosystems across the planet for well over 100 million years, alongside small, unremarkable early mammals scurrying at the margins of a dinosaur-dominated world. That long dinosaur era ends abruptly 66 million years ago, when an asteroid roughly 10 kilometers across strikes what is now the Yucatan Peninsula in Mexico, triggering the extinction of roughly 75% of all species on the planet, including every dinosaur lineage except the one that would eventually give rise to modern birds. In the aftermath, mammals rapidly diversify into the ecological niches left behind, eventually producing, after tens of millions of additional years of evolution, primates, then early hominins in Africa, and finally, roughly 300,000 years ago, our own species. Throughout this same final act, Earth has also cycled repeatedly through ice ages and warmer interglacial periods, driven by subtle variations in the planet's orbit and axial tilt, with the most recent glacial period ending only around 12,000 years ago, just as human populations began experimenting with agriculture for the first time. Step back from all four acts at once, and the shape of the overall story becomes genuinely striking. Nearly 3 billion years, the entirety of Act 2 produced nothing more complex than single cells. The transition to complex, visible life took up only the final fraction of Earth's total history, and within that already compressed final stretch, the specific lineage that became human beings represents a vanishingly small final sliver. Earth did not need complexity to survive for most of its history, and it did not need us at all for the overwhelming majority of its 4.5 billion years. We are an extraordinarily recent development on a planet that spent billions of years patiently rearranging continents, building and collapsing ecosystems, freezing nearly solid and recovering, and absorbing catastrophic impacts long before anything capable of telling this story ever existed to witness it. It's worth pausing within Act 2 to address a question that naturally arises once you understand just how long Earth spent hosting nothing more complex than single cells. What exactly were those microorganisms doing for nearly 3 billion years, if not building toward something more elaborate? The honest answer is that they weren't building toward anything at all, at least not in the sense of working toward some inevitable destination. Evolution doesn't operate with a goal in mind, and single-celled life during this period was, by every available measure, remarkably successful entirely on its own terms, diversifying into an enormous range of biochemical strategies for extracting energy from sunlight, chemical reactions, and each other, colonizing environments ranging from shallow coastal waters to deep ocean vents to, eventually, the insides of other cells. Mitochondria, the energy-producing structures found in nearly every cell in your own body right now, are themselves the descendants of free-living bacteria that were engulfed by a larger cell at some point during this long middle act, and gradually became a permanent integrated part of it, a partnership called endosymbiosis that represents one of the most consequential evolutionary events in this entire 4.5 billion year story. Despite happening quietly at a microscopic scale with no fossil record dramatic enough to make headlines the way dinosaur extinctions do, there's also a deeper irony buried within this long middle act, worth sitting with directly. The eventual rise of complex oxygen-breathing life, including every animal that has ever existed, depended entirely on a biological catastrophe that happened over 1 billion years earlier. The Great Oxidation Event, in which photosynthesizing microorganisms poisoned much of the existing biosphere with their own oxygen-rich waste product. Every animal alive today, including you, breathing oxygen as an absolute biological necessity, is in a very real sense living inside the long-term atmospheric consequence of an ancient mass extinction caused by microscopic organisms terraforming their own planet without any awareness that they were doing so. Catastrophe and opportunity throughout nearly this entire story turn out to be far more tightly linked than most retellings of Earth's history tend to acknowledge. There's a second mass extinction worth including within Act 4 that often gets overshadowed by the more famous catastrophes bracketing it on either side. Around 201 million years ago, at the boundary between the Triassic and Jurassic periods, a significant extinction event eliminated a substantial share of both marine and terrestrial species, likely driven by another episode of intense volcanic activity disrupting global climate and ocean chemistry. The ecological vacancy left behind by this event is widely considered a major factor in allowing dinosaurs, who had existed alongside larger, more dominant reptile competitors up to this point, to rapidly expand into the dominant large-bodied land animals for the next 135 million years. It's a pattern that repeats with almost mechanical consistency across this entire fourth act. Dinosaurs rise on the heels of one mass extinction, dominate for an immense stretch of time, and are then themselves eliminated by an entirely different catastrophe 66 million years later, clearing space for the mammalian radiation that eventually produces every animal you've ever kept as a pet, eaten for dinner, or seen at a zoo, including the specific lineage that became us. It's worth closing this fourth act, and this entire four-part story, with one final point about scale that's easy to state but genuinely difficult to internalize. The ice age cycles that have shaped the most recent stretch of Earth's history, swinging the planet between extended glacial periods and shorter warm interglacials, are driven by remarkably subtle variations in Earth's orbital shape and axial tilt. Changes so small that, on any human timescale, they would be essentially undetectable without precise instruments. And yet, compounded patiently over tens of thousands of years, those subtle variations have been enough to repeatedly bury entire continents under kilometers of ice and then melt them free again, and again, throughout just the final, tiniest fraction of this planet's overall history. We are, right now, living inside one of the warm interglacial windows produced by this same ongoing cycle, a window that opened roughly 12,000 years ago and that made human agriculture and everything that followed from it possible in the first place. 4.5 billion years of violent formation, billions of years of patient microbial transformation, an explosion of complexity, and repeated waves of catastrophe and recovery, all of it converging on this single, narrow, climatically stable window. The exact window in which you happen to be alive to hear this story told.